A silent traveler races through the solar system, darker and heavier than anything its size should be. To the naked eye, it looks like nothing more than a speck of light. But to the instruments trained on it, the signals are growing stranger by the day. This is 3I Atlas, only the third confirmed interstellar object in human history. At first, it seemed to be just another comet. Unusual, yes, but still explainable. Then came the anomalies. A thermal pulse beating like a clock from deep inside. A radio burst repeating across continents. A sudden flare 40% brighter in less than an hour. And finally, the unthinkable. The models predicting its orbit began to fracture. Its path bent closer toward Mars. Now astronomers face a possibility they have never confronted before. 3I Atlas may not survive its passage. The stresses building inside it, chemical, mechanical, or something else entirely, could tear it apart in a violent explosion. If that happens, the fragments will not simply drift harmlessly into the void. They will surge outward in a storm of dust, plasma, and high-energy particles, shockwaves rippling down the line of the solar wind. Mars is directly in the path, but Earth may not be beyond reach. The clock is ticking, the evidence is mounting, and the question grows harder to avoid. Are we watching a comet, or the countdown to a detonation on a scale we have never seen? Explosions in space are not unfamiliar to astronomers. Stars collapse, supernovae release more energy in seconds than the sun will emit in its lifetime, and smaller bodies like comets and asteroids have been observed to break apart before. Shoemaker-Levy 9 fragmented under Jupiter's gravity in 1992, its pieces colliding with the planet 2 years later in a series of spectacular impacts that scarred its atmosphere. Comet 17P Holmes surprised the world in 2007 when it suddenly brightened by a factor of 1,000,000 in less than 48 hours, ejecting a vast shell of dust. These events were powerful but not unprecedented. With 3I Atlas, however, the context is different. This is not a local comet, a leftover from the formation of our own solar system. It comes from somewhere else entirely, carrying chemical signatures and structural properties no one has ever seen before. The risks are not just scientific unknowns, they are existential questions. What makes astronomers nervous is not just the possibility of fragmentation, but the scale. The estimates put the mass of 3I Atlas at over 33 billion tons, far too large for a normal comet. If such an object were to rupture, the debris cloud would dwarf anything in recorded history. High-velocity fragments would scatter across millions of kilometers, each piece potentially large enough to carve craters or disrupt orbits. The dust and plasma released could create electromagnetic storms as they interact with the solar wind, disrupting communications, satellites, and possibly even power grids on Earth. While space is vast and shockwaves dissipate quickly, the interconnectedness of the solar system means that no event on this scale happens in isolation. The chemistry of 3I Atlas deepens the puzzle. Unlike typical comets, dominated by water ice and carbon monoxide, this object is rich in carbon dioxide, 8 times more than water by some measurements. Such a composition is unknown among comets studied in the solar system. Carbon dioxide ice sublimates rapidly under sunlight, and if layered within the object, it could create pressure pockets. As heat penetrates, these pockets may burst explosively, like buried bombs triggered one by one. The heartbeat pulses detected every 4 hours could be the signature of these cycles, building and releasing pressure in regular intervals. If multiple chambers rupture at once, the entire nucleus could fail catastrophically. The thermal and radio anomalies add to the unease like fuel to a fire already burning. Both Hubble and the James Webb Space Telescope have now confirmed what no one expected to see: periodic flashes of heat, a pattern as if the body were warming and cooling in cycles far too regular to be explained away as random outgassing. A comet is supposed to behave chaotically, jets firing from fractured surfaces when sunlight strikes volatile ices. But 3I Atlas does not act like a snowball venting steam. It pulses, its energy building and releasing with a rhythm. Instruments in orbit and on the ground have synchronized to the same unsettling beat, a heartbeat echoing across millions of kilometers. At the same time, the world's most sensitive radio arrays, from China's FAST telescope to Europe's LOFAR network, have logged bursts of narrowband emissions that align almost perfectly with those thermal peaks. Radio noise is common in space. Quasars blaze, pulsars tick, the sun itself crackles. But those are broad and wild, chaotic across the spectrum. What Atlas produces is narrow, precise, and coincident. The alignment across wavelengths is what unnerves researchers. Heat and radio, two different channels of physics locked together in repeating intervals. Nature is clever, but not often so coordinated. Skeptics argue for exotic chemistry. Perhaps carbon dioxide, dominant in 3I Atlas, is undergoing a kind of phase transition deep beneath the crust, its expansion and contraction timed by the sun's steady radiation. Some theorize about crystalline ice lattices, expanding and collapsing like giant lungs. Others suggest resonance, layers of ice and dust acting like a bell, ringing in harmony with thermal stresses. All of these explanations remain possible, but none sit comfortably. None explain the sharpness of the radio bursts, the clockwork precision of the cycles, or the persistence across months of observation. And so the speculation shifts. If such regularity is not accidental, then what is it? Could this be the functioning of systems hidden beneath the surface, relic machinery, or even the operational components of something more deliberate? For decades, SETI researchers dreamed of narrowband signals as the hallmark of intelligence. What they expected to find was a beacon sweeping across the stars. What they did not expect to find was a comet-like body broadcasting its pulse in rhythm with its own thermal fluctuations. Mars now finds itself at the very center of this debate, by sheer coincidence, or by something more. 3I Atlas is on course to pass alarmingly close to the red planet. Orbital models predict a near approach within a few million kilometers, close enough that if the object disintegrates near perihelion, Mars will be directly in the line of fire. Its atmosphere, thin as a wisp compared to Earth's, offers little protection. Even modest fragments could slam into its surface, carving craters and ejecting dust high into the skies. A major shower could choke the atmosphere in haze for months, dimming the sun and frustrating the solar-powered rovers crawling across its surface. The risk is not limited to hardware. Planetary protection officers are quietly voicing a more unsettling concern: contamination. 3I Atlas is not from here. Its chemistry is unlike any comet ever seen, and it may carry compounds or even organic material foreign to our solar system. If fragments survive to reach Mars's surface, they could seed the planet with molecules we have no defenses against, or, more optimistically, provide the first direct samples of interstellar material in human history. To some, this is danger. To others, it is opportunity. Imagine scooping up a shard of a body forged around another star, reading its isotopes like a history book, or scanning it for the building blocks of life. But such a prize comes only if humanity is prepared, and fast. Earth, while farther away, is not beyond concern. The solar system is bound together by invisible currents. The solar wind carries charged particles outward at hundreds of kilometers per second, and a major outburst from 3I Atlas could ride this conveyor belt straight toward us. The historical parallel is chilling. In 1859, a massive solar flare struck Earth, producing the Carrington event. Telegraph wires sparked, fires broke out, and auroras lit the skies as far south as the Caribbean. In today's world of satellites, GPS, and power grids, a geomagnetic storm of similar magnitude would be catastrophic. Banking, aviation, internet infrastructure, all could be paralyzed. While no one expects an interstellar comet to rival the sun in energy, the truth is more sobering. We don't know how much energy Atlas contains. Its mass is colossal, its chemistry alien, and the consequences of a sudden detonation remain speculative. But it does not take a direct hit to alter civilization. A cloud of charged dust sweeping past Earth at the wrong time could be enough. And so the whispers return to the vessel hypothesis, an idea once confined to fringe forums, but now intruding into professional circles. What if 3I Atlas is not a comet at all, but a vessel? The suggestion feels outrageous, but history has primed us to consider it. In 2017, Oumuamua, the first known interstellar visitor, streaked through our solar system with anomalies no one could reconcile. Its elongated shape, its lack of a visible tail, its strange acceleration that defied models.
For years, astronomers argued. Some insisted on exotic but natural explanations. Others, like Harvard's Avi Loeb, proposed the unthinkable. It might have been a probe, a piece of alien technology passing silently between the stars. Many dismissed the claim, but the precedent lingers.
Now comes Atlas, heavier, stranger, and more volatile. If one object looks suspicious, why not another? And this time, instead of simply slipping past us, it bends its path closer to a world within reach, Mars. The planet that humanity has marked as its next frontier is suddenly framed as a stage for something much larger. The symbolism is almost mythic. As we prepare to step outward, another intelligence, or the remnant of one, may already be converging on the same destination. The vessel hypothesis forces questions that humanity has never had to ask. If it is truly a craft, what is its purpose? Exploration? Observation? Colonization? Is it crewed, carrying beings across the Gulf of Stars, or automated, drifting silently on orders set eons ago? Could it even be derelict, a ghost ship from a civilization long gone, its systems running on autopilot as it crosses the galaxy? And if it is intact, what will it do when it nears Mars? Will it ignore us? Will it respond? Or will its instability prove to be something intentional, a design, not a failure, preparing for a final act? Astronomers can model orbits. They can measure heat and radio waves, but they cannot yet answer the deeper question. What is 3I Atlas? If it is a comet, then its explosion will be a natural catastrophe on a scale humanity has never seen. If it is a vessel, then its approach to Mars is not random, and the stakes are higher than science alone can measure. The possibility of an explosion complicates the vessel idea further. If the signals we see are not natural, then perhaps the instability is not accidental either. Could 3I Atlas be designed to break apart, a delivery system scattering payloads across Mars, a self-destructing probe hiding its technology before we can study it, or simply the decay of something ancient and failing, too far from its makers to be repaired? These are the speculations now surfacing in late-night conferences and private forums. None have evidence, but all feed into the unease. For now, the cautious path is observation. Every major observatory on Earth is aimed at 3I Atlas. NASA and ESA have tightened control over data pipelines, citing planetary security. Amateurs with backyard telescopes track it as best they can, uploading images to forums where each pixel is dissected for anomalies. Citizen scientists are playing a role not seen since the days of Galileo, providing independent checks on official narratives. The distrust runs deep. When NASA's feed cut during a previous orbital shift, suspicion surged. Transparency is now a currency as valuable as the data itself. If 3I Atlas does explode, the event will not be subtle. It will brighten suddenly, a flash visible even to small telescopes. Fragments will scatter, some glowing with sublimating ice, others dark as charcoal. Dust will spread into a massive coma, potentially stretching millions of kilometers. Instruments across the solar system, from Mars orbiters to the Parker Solar Probe, will register the surge. The shockwaves will ripple outward, and humanity will confront the aftermath together. For planetary defense offices, this is a scenario to prepare for, not dismiss. Still, there is one more chilling possibility. Some theorists suggest the pulse and the burst are not just byproducts of instability, but a signal, a beacon meant to be noticed. If so, then perhaps the approach to Mars is not coincidence. Perhaps it is rendezvous. If true, then humanity is not just an observer but a participant, whether ready or not. The thought is difficult to absorb. A vessel aimed at Mars, closing the distance with every passing hour. If it is a natural comet, it will disintegrate or fly by, leaving mystery in its wake. If it is more, then history is about to divide into before and after. Before 3I Atlas, when we wondered if we were alone, and after, when the question is answered not by silence, but by the arrival, or the detonation, of something from the stars.